This lesson covers determining domain and range of a linear function given a graph. So let's look at number 1. The graph of a part of a linear function f is shown on the grid below. What are the domain and range of the part shown? Well, let's first talk about domain and range. So domain are all the x values that make a function true, and range are all the y values that make a function true. So we're going to look at the domain first. And so domain is all your x values. So you're going to want to look here on your x-axis. And what I'm going to do is I'm going to look left to right to see where my function starts and stops. And so it starts here at -8. And then if I look across to the right-hand side, it goes to +8. Okay? So I know that for my domain, I start at -8 and I end at +8. This is continuous data, so that means it's a straight line, which means all the partial values in between these whole points also count to make this function true. So the next thing I need to look at is what type of endpoint my function has. And this endpoint has a solid dot as its function endpoint, which means on this side of my inequality sign, I'm going to have the equals to bar underneath. Because what we're saying is that for this function, -8 is inclusive as one of the points that make this statement true. But when I look on the right-hand side over here, notice that the coordinate, the endpoint on the right-hand side is open. That means that 8 is not included in the values that make this function true. So we have -8 on the left-hand side boundary, and we have +8 on the right side boundary. And then based on what type of endpoint I have, whether it's closed or open, tells me whether or not I include that point in the values or not. And so now let's do the same process for our range, and I'm going to do that one in green. So the range is our y value, so we'll be focusing on the y-axis. And I'm going to start at the bottom because the bottom is going to be the left side boundary of my inequality statement. And so if I move up from the bottom, I want to start at the lowest point from the bottom to the top, and the lowest point is here at 0. And then when I look up to the highest point right here, it is at 4. So on the bottom, I have 0. And then the top boundary is 4. Now, where I'm located at 0 is the closed dot. So that means that I am going to include the equal sign in that inequality. And then on the right side boundary, it's open, which means I am not going to include that. So 4 does not make that statement true, but every value up to 4 does. And so this would be my domain for my x values. And this would be the inequality statement for my range, which is all my y values. All right, let's look at number 2. Function g is graphed below. What are the domain and the range? So my domain are my x values. My range are my y values. I'm going to grab my yellow highlighter again, and we'll start with the domain. And so remember, the domain is going left to right, looking across my x-axis. And so I'm starting on the left side boundary of my function, and I'm going to line that up on my x-axis so it is starting at -4 on the left-hand side. And then if you'll notice here on my right side boundary is an arrow. And that arrow means that my line is extending out infinitely, and that means that all real numbers beyond -4 make this statement true or make this function true. And so how I'd write that would be an inequality statement, but it does have a starting point. So our domain We're going to start with X because this is an inequality statement. And so X is doing something. My X values are doing something. Well, my X values are starting at -4, and they are moving to the right, and they are getting bigger than -4. Notice I don't put the line under my inequality sign because it is open on this left side boundary. So X is greater than -4. So any number greater than -4, not equal to -4, makes this statement true, or this function true. And then for our range, we're going to be looking at the x-axis to see what pattern of behavior our y numbers are doing. And so the same thing happens again. I'm going to start looking at my range. And remember, we started at the bottom on this one. So I'm going to do the same thing here. And notice that I have an arrow on this side, which means I know that that's all real numbers, right? And so if I look up here on my y at 5, my y values are getting smaller, right? Because they're moving in a direction where y values are getting smaller. But it is starting at 5. It's not inclusive of 5. And unlike my x's that were getting bigger going to the right, since my arrow is headed down, my y values are getting smaller. And so we'll say that y is starting at 5, and all those numbers that make it true for y are less than 5, and that would be my range. Let's try a couple more. Number 3, a company is hiring an electrician for a building project. The graph shows the electrician's cost for working a maximum of 8 hours per day. What are the domain and range of the function for this situation? So we have domain and we have a range. In this system, these applied problems, they give you an idea of the boundaries, right? Just based off the scenario. And then they also include that information in the graph to make it easy for me to determine what the domain and range are. So in yellow, we're going to highlight the domain. So my domain is along my x-axis. So notice this graph is only of quadrant 1. So both my x and y values are all positive. And then it's limited, right? It starts and stops. So it starts here along the x-axis on the left-hand side. It starts at 0. And then if I move across to the ending of my function, it stops at 8. All of my x values are between 0 and 8 for this function. And they include 0 and 8 because I have a closed dot at the end, or a filled in dot at the end, which means that it does include 0 and 8 in the values for this function. So I have 0 as my left boundary. I have 8 as my right-hand boundary. My x values are in between these two values. And because it includes those, I'm going to use the equal to inequality. And so my domain for this function is between 0 and 8. Our next one, I'm going to do in green, our range. And again, we're going to start at the bottom. And we notice our function starts here at 100. And then I move to the top of my function looking at my left, and I'm right here. And it looks like my each hash mark is worth 50. So I'm going to mark this graph that this ends at 650. So sometimes the numbers that we're looking for are not on the graph. They're in between the numbers. So it's important that you look and read your graph and look at the hash marks to figure out what you're counting by, so you're able to give the correct value to the end or the beginning of your inequality statement. And so we're going to start at 100 as the lowest boundary on my range. And we're going to go all the way up to 650 at the top, which is the right-hand side of my inequality statement. And y is between these two values. And because it's closed out on both ends, I'm going to use the same inequality symbol. So your inequality symbols should match up. And so when we're talking about a multiple choice test, if I have a closed dot on both ends of my function, then both of my inequality statements, as long as the data is continuous, will be written in this format. And then let's try our last one, number 4. Savannah is shopping for avocados. The graph shows the amount of money in dollars that Savannah has left as a linear function x, the number of avocados purchased. Notice that our data is in dots because it's discrete, because we're not buying half avocados at the store. You're buying individual avocados. And so my domain is not going to be written as an inequality statement. So you'll notice on some of the work that I've provided for you, and you'll notice in the explanations, you'll see that when I see a discrete data graph, I always make a little note to myself that it is not an inequality statement. So for our domain and range, we're going to do the same thing, looking along the x and y axis for the start and stop of our function. And basically, discrete data functions, if I wrote all of these points as coordinates, then my domain and range, the domain would be the list of all the x values for the coordinates, and my range would be the list of all the y values for the coordinates. So let me show you what I'm talking about. So in yellow, we'll start the domain. And so my domain, I'm going to look here on the left, and I have a point at 0. But then I don't have another point again till 1, 2, 3. So you'll notice I have individual points from 0 to 10. And so my domain will be written as a list from 0 to 10. Now, when we write lists, it's important to know when you write them out as individual numbers that no matter what order they are on your graph, when we write them in a list like this, we write them from least to greatest, from left to right. And so your values might not be in the same order inside these parentheses or these brackets as they are on the function. And that's okay, because we write these least to greatest. And so that's important when you're looking at a multiple choice answers. You want to pick the one that is written correctly. And now for our range, we are going to pick the corresponding y values. Now notice my y value here at 0 is 14, or excuse me, 15. Make sure we make a note of that. That is 15 here. And so we've got to be mindful of these little half marks here. So notice this one looks like it's at 13.5. So it looks like it's changing by 150 each time, and it is because my next value is at 12. And so I'm going to kind of use this pattern. So at 0, I'm at 15. So I'm actually going to write my range backwards, only because it's going to be easier for me to do that way, because my larger numbers are actually starting here on the left. And so when we get to 0, our number is, our range at 10 is 0. And then we would have 1.5 and 3. And I'm just going to put dots here in between, but you'll notice. So if we wrote it as coordinates, like our first coordinate is 0, 14. Or 15, excuse me, 15. I keep saying 14 because I can't see that 15 on the graph. 0, 15. And then I would also have a point at 1, 13.5. And so notice when I write them as coordinates, This x is included in my domain and the y is included in my range. And that's just a quick little lesson on determining the domain and range for partial linear functions.